There is a possibility that right now, at this very moment, someone is trying to speak to us from another galaxy, not in science fiction, not in fantasy, but in real time, somewhere in the endless darkness of space, a signal could already be on its way toward Earth. And yet, we may never hear it, not because no one is there, not because life is rare, but because the universe itself may refuse to let the conversation happen. This is one of the most unsettling ideas in modern science. The universe could be filled with intelligent civilizations, thousands, millions, even more, spread across billions of galaxies, each galaxy containing billions of stars. And many of those stars likely have planets like Earth. That means the number of possible worlds with life is almost beyond human comprehension. Some of those civilizations could be far more advanced than us. Some may have already discovered physics we do not even understand yet. Some may already be trying to send messages across space, hoping someone listens, but there is a hidden problem that most people never think about. Communication is not just about intelligence. It is not just about technology. It is about the rules of the universe itself. In everyday life, communication feels instant. A message is sent and a reply comes back in seconds. Even across Earth, the delay is almost unnoticeable. This creates a false sense of control. It makes us believe that if we can build powerful enough tools, we can talk to anyone, anywhere. But space does not follow human expectations. Space follows physics. And according to modern physics, there is a hard limit to how fast anything can travel. This limit is not a suggestion. It is not a technical challenge. It is a law of nature. It is the speed of light. Nothing carrying information can move faster than this. Not signals, not radio waves, not lasers, nothing. This single rule changes everything because the universe is not small. It is enormous beyond intuition. The Milky Way galaxy alone is about 100,000 light years wide. That means a message sent from one side of our galaxy would take 100,000 years to reach the other side. And that is only within a single galaxy. Now zoom out. There are billions of galaxies in the observable universe. Some of them are millions or even billions of light years away. If a civilization in another galaxy sends a message toward us, that message might take millions of years to arrive. By the time it reaches Earth, the civilization that sent it may no longer exist. This creates a strange and silent reality. A message can be real, meaningful, and intentional, yet completely useless by the time it arrives. And there is something even more disturbing. Even if we manage to send a reply, that response would take the same amount of time to return. This is not a conversation anymore. It is two isolated messages separated by deep time. A civilization could send greetings and never live long enough to hear an answer. This is where the idea of communication across galaxies starts to break down. Most people assume that advanced technology solves distance, stronger antennas, more powerful signals, better encoding systems. But none of that changes the speed limit of the universe. No matter how advanced a civilization becomes, they still live inside the same cosmic rules. Brian Greene, one of the most respected theoretical physicists, often explains that space-time itself is not just a background, it is an active structure that defines what can and cannot happen in the universe. Relativity tells us that time is not universal. It stretches and bends depending on motion and gravity. And because of this, even the idea of a shared now across galaxies begins to disappear. There is no single moment in time that connects the entire universe. What is happening now in one galaxy may already be ancient history in another. Or it may not have happened yet from a different point of view. This removes the foundation needed for real communication because communication requires timing, it requires response, it requires shared understanding of when something is happening. But in a universe shaped by relativity and vast distances, Those shared moments do not exist in any practical sense. So the question becomes even deeper than just whether aliens exist. It becomes whether connection is even possible. In this video, we will explore why communication across galaxies may not just be difficult, but fundamentally impossible according to the laws of physics. We will break down how light speed limits every message in the universe. We will uncover how cosmic expansion pushes galaxies away from each other forever. We will see how signals weaken and disappear into noise long before they reach their destination. And we will understand why even advanced civilizations may be trapped in complete isolation no matter how hard they try to reach out. By the end, the universe will not feel like a connected place. It will feel like something much stranger, a place filled with countless worlds that may never know each other exist. And now, welcome to the channel. If you are interested in deep science, space mysteries, and the hidden rules that shape reality, subscribe and stay with us. Because the universe is far more silent than it first appears. Light is the fastest possible signal in the universe. Nothing in nature outruns it. Not particles, not energy, not information, itself. Every message we send into space is trapped inside this rule. Radio waves, laser beams, even the most advanced future communication systems all move at the same cosmic speed limit. This speed feels extremely fast on human scales. A message can circle Earth in a fraction of a second. It can reach the moon in just over 1 second. Even Mars, at its closest point, only adds a delay of a few minutes. This creates the illusion that space is manageable. That distance is just a problem of engineering, but that illusion disappears quickly when the scale changes. The Milky Way galaxy alone is so large that light takes about 100,000 years to travel from one end to the other. That means a signal sent during early human civilization would still be traveling through space today, and that is just inside a single galaxy. Now stretch that distance further. Between galaxies, the gaps are not measured in thousands of years of light travel, but millions. The Andromeda galaxy, our closest large neighbor, is more than 2 million light years away. Any message sent toward it today would arrive in a future so distant that Earth itself will not remain the same planet. Andromeda is considered nearby in cosmic terms. Many other galaxies are far more distant. Some are so far away that their light has not even reached us since the beginning of the universe. This is where communication begins to fail in a strange way. A conversation requires exchange. One message sent, one message returned. But in space, the reply is delayed by millions or even billions of years. A single question may take longer to receive an answer than the entire history of human civilization. Civilizations do not last that long. Technology changes. Species evolve. Planets shift. Entire worlds can rise and disappear in less time than it takes for a message to make one round trip. There is a deeper problem hidden inside this delay. Even if a civilization sends a powerful signal, it is speaking into a future that may never be there to listen. And by the time a response is possible, the original sender may be long gone. This turns communication into something closer to sending messages into deep time rather than across space. Relativity makes this even more strict. The speed of light is not just a high-speed limit. It is a boundary built into the structure of space-time itself. It defines how cause and effect work in the universe. One event can only influence another if information travels between them at or below this speed. That means no signal, no matter how advanced the technology, can bypass this rule. It is not a limitation of machines or energy. It is a limitation of reality itself. Even stranger, this rule also shapes how different observers experience time. A signal moving at light speed does not experience time in the normal way. From the perspective of physics, it connects events across vast distances, but never allows instant connection between them. So when we talk about sending messages across galaxies, we are not just talking about distance. We are talking about a universe that enforces delay as a permanent condition. And in that delay, entire civilizations can rise, send messages, and vanish before any answer ever arrives. The Milky Way is about 100,000 light years wide. This number is difficult to truly grasp. It means that even light, the fastest thing in the universe, takes 100,000 years to cross from one side of our galaxy to the other. Every star inside it exists at an enormous separation from every other star, held together only by gravity. Earth sits in one small corner of this galaxy. Our nearest stellar neighbors are still light years away. Even sending a simple signal to them is not a quick task. The closest star system, Alpha Centauri, is more than 4 light years away. That means any message we send today will take more than 4 years just to arrive. And the reply would take another 4 years to return. That is the nearest possible conversation we can have in space. And it already feels broken. Now step further out. The nearest major galaxy to us is Andromeda. It sits more than 2 million light years away. That number is so large that it stops behaving like a normal distance. It becomes a measure of deep time instead of space. A signal sent from Earth today toward Andromeda would not arrive in any meaningful human future. It would reach its destination millions of years later. By that time, Earth would no longer be the same planet. The continents would have shifted. Species could be different. Civilizations, if they still exist, would be unrecognizable. Even if another civilization received the message and replied instantly, the response would take another 2 million years to return. This turns communication into something that no longer resembles dialogue. It becomes a slow echo stretched across cosmic history. There is a lesser-known consequence of this delay. It removes the idea of a shared present. In everyday life, communication depends on a sense of now. A conversation feels real because both sides exist in the same moment. But across galaxies, that shared moment disappears completely. What is happening in one galaxy is already ancient history in another. A message received is never current information. It is always a record of the past, sometimes an extremely distant past. Even stars that seem close in cosmic terms create this distortion. Messages between nearby stars take years or decades to travel. That means any discussion between civilizations would feel like reading letters written by people who may no longer exist by the time the reply arrives. This creates a strange reality. Every attempt at communication becomes a time capsule. A civilization is never speaking to another civilization as it exists right now. It is always speaking to its past. And in many cases, that past may be so old that the sender and receiver are no longer aligned in time at all. Some astrophysicists describe this as a breakdown of simultaneity. There is no universal present across space. Each region of the universe lives in its own timeline, separated by distance and the finite speed of light. So even before considering technology or intelligence, the universe already removes the possibility of real-time dialogue. It replaces it with delays that stretch far beyond the lifespan of any known civilization. Space is not static. It is stretching. Every moment, the fabric of the universe expands. Galaxies are not only separated by distance, they are being pushed apart by the expansion of space itself. This process is driven by something called dark energy, a force we cannot see and still do not fully understand. At first, this sounds like a slow process, something happening over billions of years. But on cosmic scales, it changes everything about communication. Distant galaxies are not fixed targets. They are moving away from us, and they are doing it faster as time goes on. The more space there is between objects, the more space expands between them. This creates a strange effect where distance itself grows even without motion through space. There is a lesser-known detail that makes this even more extreme. Some galaxies are not just moving away from us. They are receding faster than the speed of light when measured by the expansion of space. This does not break relativity because nothing is moving through space faster than light. Instead, space itself is stretching faster than light can cross it. This creates a boundary in the universe that is often called the cosmic event horizon. Beyond this boundary, communication is not just delayed, it is permanently impossible. If a civilization exists beyond this limit, any signal we send will never reach them. Not in a million years, not in a billion years, not ever. The expansion of space carries them away faster than our message can travel toward them. Even more surprising, this horizon is not fixed. It is slowly growing in a way that isolates more of the universe over time. Regions that are currently reachable may eventually drift beyond communication range in the far future. This means the visible universe is not fully accessible. It is divided into a region we can potentially interact with and a region we can never reach, no matter how advanced our technology becomes. There is a quiet consequence to this that is rarely discussed. It means that parts of the universe may already be lost to us without any dramatic event. No explosion, no disappearance, just gradual separation caused by expansion. Signals sent toward distant galaxies do not simply travel through empty space. They travel through space that is stretching faster than they move forward. In some cases, the destination moves away faster than the signal can approach it. The message never closes the distance. It falls behind forever. This turns communication into something far more fragile than distance. Alone, it becomes dependent on whether space itself allows the message to ever arrive. Even the most powerful civilizations would face this limit. No energy source, no technology, no level of intelligence can reverse the expansion of the universe. It is not something that can be engineered around. It is part of how the universe evolves. So when we think about sending messages across galaxies, we are not just dealing with distance or time. We are dealing with a universe that is actively increasing the gap between every point, slowly locking regions of reality away from each other permanently. Every signal sent into space begins to weaken the moment it leaves its source. It spreads outward in all directions like ripples on a pond that grow wider and thinner as they expand. This follows a strict rule of physics known as the inverse square law. The further a signal travels, the more its strength drops. At short distances, this loss is manageable. A radio signal from Earth can reach spacecraft, satellites, and nearby planets with no serious issue. Even across the solar system, powerful transmitters can still send readable data. But the situation changes completely when the distance becomes interstellar or intergalactic. A signal aimed at another galaxy does not travel in a straight contained beam. It expands into a vast sphere. By the time it reaches its destination, it has spread across an enormous volume of space. The energy that once carried meaning is now stretched extremely thin. At that point, the signal is no longer strong. It becomes faint, then weaker, then barely detectable above the background of the universe. And space is not silent. It is filled with constant noise. Cosmic microwave background radiation is everywhere, a faint echo from the early universe. There are also emissions from stars, pulsars, black holes, and countless other natural sources. Even empty-looking regions of space are filled with subtle electromagnetic activity. On top of that, there is dust scattered across galaxies, bending and scattering signals as they travel. This creates distortion and interference that grows stronger over distance. So by the time a message crosses intergalactic space, it arrives in a very different condition than when it left. It is not just weaker. It is buried inside layers of natural cosmic signals. This creates a serious problem. An intelligent message from another civilization would have to compete with a universe already full of static. The difference between signal and noise becomes extremely small. There is a lesser-known challenge hidden inside this. Even if a signal is detected, recognition is not guaranteed. Without a shared structure or common reference, it is difficult to know if a pattern is artificial or just a natural fluctuation in radiation. The universe does not label its messages. This means that even a successful detection might not be understood. The signal could be there, but its meaning could be completely lost. Some scientists compare this to trying to hear a single voice in the middle of a storm that never stops. The farther the source, the harder it becomes to separate intention from randomness. There is also the issue of compression over distance. As signals weaken, data becomes harder to preserve. Missing pieces can destroy entire messages. A single lost fragment might remove the structure needed to decode everything else. Even if a civilization sent a perfectly designed message, it would still face this degradation. The universe does not preserve information in its original form over such extreme distances. It breaks it down, scatters it, and blends it into the background. So the challenge is not only sending a message across galaxies, it is making sure that after millions of years and countless distortions, there is still something recognizable left to receive. Even if distance was not a problem, even if signals stayed strong and clear, there is still another barrier that quietly destroys communication across the galaxy. It is not space itself, it is time. Civilizations do not rise and fall together. They appear at different moments in cosmic history, separated by millions or even billions of years. A civilization can exist for a brief window, send messages into space, and disappear long before any reply could ever arrive. This creates a timing problem that is easy to underestimate. A civilization on one planet might develop technology capable of sending signals into deep space. They may broadcast messages for thousands of years, hoping for contact, but the universe is not listening in real time. Those signals are moving slowly across vast distances, while the sender may already be gone. On another world, a different civilization might not even exist yet. Life could still be simple. Oceans forming, atmospheres stabilizing, intelligence still far in the future. By the time this second civilization evolves the ability to receive signals, the first civilization's messages may already be long gone or too faint to detect. There is a lesser-known consequence hidden in this delay. Even when two civilizations exist in the same galaxy, their technological timelines may never align. One may reach advanced communication millions of years before the other even becomes capable of understanding it. By the time both sides are ready, they are no longer synchronized. One message may arrive too early before the receiver exists. Another may arrive too late after the sender has vanished. This creates a universe where communication depends not only on distance, but on perfect timing across unimaginable scales. The probability of two civilizations overlapping at the right technological stage becomes extremely small. It requires both to develop intelligence, build communication systems, begin transmitting signals, and remain active long enough for messages to cross the gap between them. This overlap is not impossible, but it is incredibly rare. Because of this, some scientists describe a concept that feels almost unsettling: a cosmic loneliness window. This is the idea that civilizations may exist in the universe, but their periods of activity never align in a way that allows contact. One civilization may live millions of years before another even begins. Another may thrive long after the first has disappeared, each one sending messages into space, each one receiving silence in return. There is also a deeper layer to this problem. Even if two civilizations existed at the same time in cosmic terms, their definition of time may differ due to relativistic effects. Their perception of now may not match at all, making synchronization even more complicated. So the universe does not just separate civilizations by space, it separates them by time itself. And in that separation, even the most advanced attempts at communication begin to feel like signals sent into different eras that never truly meet. One of the most common ideas linked to deep space communication comes from quantum physics. It sounds powerful at first, strange, almost magical. Two particles can become connected in a way that links their states instantly, no matter how far apart they are. This is called quantum entanglement. At first glance, it seems like a possible solution to the communication problem. If two particles are connected across any distance, it feels like information could travel instantly between them, faster than light, across galaxies, across the universe. But reality is far more restrictive. Quantum entanglement does not allow usable information to be sent. When one particle is measured, the result on the other side appears instantly correlated. But the key detail is that this outcome cannot be controlled. It is random. There is no way to force a specific message into the system. This is a lesser known point that often gets lost in popular explanations. The correlation is real, but it cannot be shaped into communication. It does not allow signals. It does not carry meaning. It only shows that two systems are linked in a way that defies classical intuition. Because of this, entanglement cannot bypass the speed of light. It cannot be used to send messages across space. It cannot bridge galaxies. It cannot connect civilizations separated by distance. Relativity still stands untouched. Physics places strict rules on how information moves through the universe. Any transfer of usable data must obey the speed limit of light. This is not a limitation based on current technology. It is a structural rule of space-time itself. It defines how cause and effect operate. Even the most exotic quantum effects do not break this rule. There is a deeper reason for this restriction. If information could travel instantly, it would create contradictions in time and cause. Events could influence each other in ways that break the order of reality. Physics avoids this by ensuring that no information transfer can happen faster than light, even at the quantum level. This is why entanglement feels strange but remains safe within the framework of physics. It produces correlations, not messages. It connects outcomes, not meanings. Some interpretations of quantum mechanics make this even more subtle. The act of measurement does not send anything across space in the way communication does. Instead, it reveals a relationship that was already part of the system. Nothing travels between the particles in a usable form. This means that no matter how advanced a civilization becomes, even if it masters quantum technology far beyond current understanding, it still cannot use entanglement to speak across galaxies. The universe protects the speed limit at every level. So while quantum physics opens doors to strange and counterintuitive behavior, it does not offer a shortcut through cosmic distance. It does not turn the universe into a connected network. It still leaves every civilization bound to the same silence imposed by space-time itself. Across everything explored, one pattern becomes impossible to ignore. The universe is not simply large. It is structured in a way that resists connection. Every layer of physics adds another barrier. Distance stretches communication into deep time. The speed of light locks every signal into delay. The expansion of space pushes entire galaxies beyond reach. Even the structure of signals themselves breaks down into noise before they arrive. And time itself refuses to align. Civilizations in any meaningful way, when all of these limits come together, the result is not just difficulty. It is silence. Not the silence of emptiness, but the silence of separation. There could be countless civilizations spread across billions of galaxies. Some may be older than Earth by billions of years. Others may still be forming right now. Some may already be sending messages into space, waiting for a response that will never come in their lifetime. Each one could be surrounded by others and yet never aware of them. The universe may not be a shared conversation. It may be a collection of isolated islands, each one surrounded by vast oceans of space and time that cannot be crossed in any practical way. Every civilization speaking into the dark, hoping for an answer that arrives too late or not at all. And at the center of all of this is not a lack of intelligence or technology. It is not a failure of engineering. It is something far deeper. Space-time itself. The structure of the universe defines the limits of connection. It decides how fast information can move. It decides how far signals can travel. It decides whether 2 points in existence can ever truly interact. Even the most advanced civilization would face the same boundaries. No amount of progress can remove the speed of light. No invention can stop cosmic expansion. No theory can rewrite the separation of time across galaxies. This leaves a difficult possibility. The universe may be full of life, but permanently divided by its own rules. A place where awareness exists in many forms, but contact between them is extremely rare or impossible. And if that is true, then every signal sent into space carries a strange weight. It is not just a message. It is a hope launched into a system that may never allow it to return. If you enjoyed exploring these ideas about the hidden limits of the universe, like the video and subscribe for more deep science stories.